Hi, I'm Jim Humble, and I want to show you how to make CDS the right way. I've been working with it here for a number of weeks now, trying to get it all put together correctly, and it's fairly easy once you understand the details. But I did want to tell you a little bit about the advantages of CDS. Now, I also wanted to say that CDS, chlorine dioxide solution, was first invented by Andreas Kalker in Spain. He's our bishop in Spain, the bishop of the Genesis 2 Church of Health and Healing. And he worked with it quite a bit with animals, mostly cows, and they got a lot of really good results from the cows. And then, of course, he started working with people on it. And I learned about it from him when I traveled there a few weeks ago. But the advantages to the new CDS are quite a few. And before I go into the advantages really close, we've been getting all kinds of good reports from CDS. And a lot of people are telling us that they think they get better results with CDS than they do from MMS. We use it with the same protocols as with MMS, but it just seems to give us some better results. So let me tell you a little bit about it. The first place, there's no bad taste. The bad taste is all gone, or 98% gone, by just because of the way it's made. And the way it's made, of course, is without the acid. Now, we simply take the chlorine dioxide that's generated by MMS, and we dissolve the chlorine dioxide gas in water. And then, of course, we call that chlorine dioxide solution, and that's what we use in the protocols, and it has been very, very successful so far. And when we do this, no acid is involved, so the chlorine dioxide gas goes into the water, and it has no acid with it. And chlorine dioxide doesn't care about whether it's acid or neutral or alkaline. In any case, it kills the pathogens that might be there, whether they like an acidic area or an alkaline area. So anyway, that's two of the advantages: no taste and no acid, which results in quite a bit less Herxheimer reaction. In other words, nausea. That means that we can make CDS a stronger drink, so that in some cases it will penetrate further into the body before it loses its power. And there we have, of course, when it was used with the animals, it was used for injection. And we haven't been able to inject it before. And of course, in cow's stomachs, a cow will just throw off the MMS the minute it swallows some. So the cow, you can't treat cows by feeding them MMS. So this chlorine dioxide can be injected into the muscles of the cow, and it does its job. And they treated 800 cows for 3 months and saved $30,000 in pharmaceutical drugs as they didn't have to use any of the pharmaceutical drugs. We've also used it on ourselves to see how it injects into our muscles, and it worked okay as far as injection into the muscles, but we don't suggest anybody do that because we don't know how much to inject so far, and we don't know which muscles are best and how to go about it. So we need to get that information to you as soon as we research it out, but don't just start injecting it into your muscles. It would be dangerous to do that. So, we've also used it for IV, intravenous injections, and it works too. And it never worked before because of the acid that was added to it, but now with no acid, it does the job a lot better. And finally, we can use it without mixing a couple of solutions. CDS, you just use it just like this. It's a bottle of CDS, a bottle of CDS, and you just use it right from the bottle. You don't mix it or anything, and so you have to use different amounts. You can't use exactly the same amount, but it's quite usable, and we make it without using ice. Now, I'm mentioning that now because a lot of people have been saying you've got to use ice with it in order to cool the water down in here, in order to get the chlorine dioxide to go in solution. But I haven't been able to prove that there's any difference between a warm water and ice water. So, this makes up right away fast, there's no big problem. So there should be no necessity of using ice water to make it with. Now, I wanted to cover a few of the other details that people are always asking about. The tubing is polyethylene. Now I'm going to show you some tubing a little bit later on in this video. The baby nipples are silicone rubber, so they are very, very unaffected by almost anything. Silicone is a very unaffected material. And we use all the same protocols with CDS that we use with MMS, but it just seems to get a better result, and in some cases a lot better, faster result. In other cases it don't seem to make a difference, but there have been people who wasn't getting a good result until they started using the CDS. So anyhow, it looks like we're into a new, stronger, happier, faster, more effective phase of CDS. You can buy a CDS from Michael Hurrah at Cox.net. Michael Hurrah at Cox.net. And so that data will be on our websites very, very soon. He just got going, so, but he's already shipped it to a number of people, so it's working out pretty fast. Saline solutions aren't necessary. You can use just water. I like to use distilled water or reverse osmosis water. Reverse osmosis for CDS is about as good as distilled water. And people keep talking about saturation. You gotta have it in cold water in order to get saturation of your water with chlorine dioxide. Well, I haven't been able to saturate it yet. you can put as much chlorine, you keep putting chlorine dioxide in there, it just keeps getting stronger and stronger and stronger. So far as I can see, it isn't necessary to reach saturation, because you can just keep adding chlorine dioxide to the solution. So it seems like that's all that happens. You just keep adding it because it continues to get stronger and stronger. So I don't see any worry about that. So what we do is we stop at 3,000 parts per million, and I'll be showing you how to recognize when you've reached 3,000 parts per million. But when you have reached 3,000 parts per million, that means that 1 milliliter equals a 3-drop dose in the protocol 1000, or equals a 3-drop dose of MMS in any protocol. So 1 milliliter is a little bit more than 3 drops, but that's because of the way this is made. And so you know how much to use, and we'll show you all of those details as time comes up. And so the next scene, I'm going to show you about how to make how the basics. I'm going to show you the basics of making it in the next scene, and that's in about 2 seconds from now. Okay, I've told you all that. Now I want to tell you the basic idea, the basic concept of what we're doing here, or at least the basic way of doing it. Now, this is a baby bottle, and this is a baby bottle. Now, I was using plastic baby bottles for a long time, but these are glass. And the reason why I switched to glass baby bottles was because they started to discolor. And here's an example of a baby bottle that discolored. I hope you can see the color there. And it just is a problem. I think maybe not a problem, but glass don't discolor. So I'm going to use glass just in case discoloring is put something into the chlorine dioxide. I don't think it can. I don't think it's possible, but who knows? The chlorine dioxide is evidently penetrating into the surface of the plastic, and that may or may not be bad, but I think it's just a good idea that we don't let it, don't take a chance. And so here is we put the charging MMS in here. We put, for an 8-ounce bottle, now this is a little more than 8 ounces, but you only have to put 8 ounces of water in here. We use 2 ounces, we use 1 ounce of MMS and 1 ounce of 50% citric acid. And we mix them in here, and it starts to give off gas right away, chlorine dioxide gas, and the chlorine dioxide gas comes over here into the water. Now we use distilled water for the most part, because distilled water, well, it don't have anything else in it. But you can use reverse osmosis water, because for what we're doing is just about as good as distilled water. Now, if we were going to make some for cattle or for injection or something like that, we would probably use IV solution here. instead of distilled water. But for taking by mouth, there's no point in putting salt in it or having a saline solution. So we use just plain old distilled water here, and we use MMS here. Now, I hate to tell you this, but several people have called up and said, well, their baby bottle exploded. Well, when I finally found out what they were doing, I found out that they were closing the top of the receiving bottle, of the baby bottle that takes the 8 ounces of liquid. They were closing the top. So there's considerable pressure generated in this baby bottle if you close it off over here. You can't close this baby bottle off. You see, there's no lid on here. It's totally open. Do not put a lid on the second bottle. Do not put a lid on the bottle that is on the CDS bottle, because you generate pressure over here, but the pressure comes over there, and of course the baby bottle exploded. Now there's one other safety feature that you can do, and that is this. If you just take this and just stick it in here, let me wet that a little bit. Now, you know, it kills all the germs, so you don't have to worry about that. But I'm just barely putting it through. It's just barely in there. It's not very in there much. So if you generate any pressure in here, this is going to pop out. So, so that's just another safety feature that you can do. But if there's no way this can explode if you leave this bottle open. It just can't. It can't happen unless maybe you got a clog right up here at the surface or something, and right up here at the top of the nipple. So, but if that's the case, then of course this should just push out. So it should be explosion proof, especially if you leave this bottle open. Okay, so that's the basics of it. You're generating it here, 50% citric acid and regular standard MMS. And you use an equal amount of each one of those, and I use 1 ounce of each one. And so this, in this case, if you can find a 2-ounce baby bottle, that's the one you want. This happens to be a 3-ounce baby bottle, but it'll work okay. It won't be a big problem with this 3-ounce baby bottle. It'll work pretty good. Now, so that's the basics of it. Now, the next thing I'm going to show you is all the things that you should buy. The next scene is all the things that you should go out and buy in order to make CDS. So I'll be back in 2 seconds. I wanted to go over with you what you should buy in order to get started. I would say the most essential thing is a hot plate. You should, the hot plate is just what you gotta have. Don't try to make CDS without the hot plate, because you'll be highly inefficient. And if you have the hot plate, you can just turn it on and let it go until the end. You can just turn it on and walk away and come back in 20, 30, 40 minutes, and it will be finished. So the whole idea behind a hot plate is that it just makes everything more efficient, because it will take every bit of the chlorine dioxide gas out of the MMS, and so you don't lose any for the most part. Now, of course, you need a pot to sit on top, and of course you always put water in the pot, and you want to have the water boiling or right at the edge of boiling, almost boiling, if not boiling, right near boiling. I prefer to have it just boiling slight amount. And so these two things are essential. Now, the other main thing that you want to buy is the glass bottles. This is a glass bottle that I use to charge with when I'm making regular CDS. And this glass bottle, of course, is a vodka bottle. It was about the only one I could find that was the right size and everything. And remember, when you're using the glass bottle, you never close the lid. You leave the lid, always leave the lid open. Now, the thing that you want to buy is this, for the tubing, this tubing is a 1/4 inch tubing with a 3/16 of an inch inside diameter, 1/4 inch out, but the inside diameter is the important one, 3/16 of an inch, and it's polyethylene or polypropylene tubing. And you can get it at most hardware stores, a lot of them have it, and so you can buy that. Now, of course, there's MMS, or citric acid, and MMS. Now, you ought to buy at least a couple of shot glasses. The shot glasses tell you, allow you to make a 1 ounce real easy, and so the 1 ounce, and then these are 2 ounces, 2 ounce glasses that you can use to do your measurements in too. So you need a couple of 2 ounce glasses and a couple of 1 ounce glasses, and Gatorade. The Gatorade is for measuring the parts per million to make sure that your CDS is strong enough. And so you can use the Gatorade, or you can use the test strips. Now these are the test strips. You get 50 of them for $10 about, and we cut them in two right down the center, so we actually get 100 for $10. And so you can use this. Gives you parts per million, but if you're out in the jungle, you won't have this. Maybe you will. Maybe you can take it with you, but a lot of times you may not have the parts per million strips, because about the only place you can buy them is in the U.S. You can order them from the U.S. and there are other places in the world you can get them too. But if you can't, you can get, believe it or not, you can get Gatorade in most jungles. So you can get that most anywhere. Now I use glass baby bottles. Now these are 3 ounce baby bottles, but I also use a 5 ounce baby bottle because it's preferable out of the 3 ounce. But I've been using the 3 ounce quite a bit too. But the 5 ounce works fine, and it of course is what you put in here, and then the MMS, or the chlorine dioxide gas, comes up from here over into here, of course. And so you need a baby bottle or two. It's nice to have a little funnel that you can use if you need it. This is sort of kind of essential if you can get your hands on it. It is a syringe that measures 50 cc's or 50 milliliters, either one. It says milliliters and cc's right on there. And so that's good for measuring the exact parts per million when we finally get to the point of measuring it. So you need that, and then a little syringe too that will give you 1 milliliter pretty accurately. So you can test that out, and this that's for testing the parts per million at the end. And I'll show you how to do all that. Now this is a bottle of, or a gallon of not distilled water, but distilled water is preferable. But in this case, this is reverse osmosis water, which is just about as good. These bottles just happen to be sitting here. They have CDS in them in different quantities. You can, being that they're sitting here, you can see that they have different quantities of CDS there. And this is the strongest one, of course. That's 24,000 parts per million. You probably won't want to make any of this. That's sort of a nuisance. But this is the 12,000 parts per million, and that's what you may want to make quite a bit of. And this is the 3,000 parts per million. You'll probably want to make that. And this is the 1,000 parts per million. You need to make this one stronger before you use it even. And this is the basics of it. Let me see, is there anything else you should buy? Well, it's a good idea to buy a pen for marking on the bottles and stuff. This is a Mark Zolot type pen. And I like to have a couple of clothespins to pin things up if you need to. And it's a pretty good idea to have a roll of tape. Clear tape would be fine, or a little roll of tape in case you might need it for one thing or another. But anyhow, that gives you most everything that you need to buy in order to do it. You should be able to get everything here for less than $50. So if you buy this and do as I show you, it'll be really easy for you to make a bottle of this every couple of weeks, and it will be very useful. And then if you want to make some really strong stuff like this, we've been getting some really good results from the real strong stuff. We've been getting it's been really good for treating various skin diseases. And the skin diseases are not, you know, you can treat it and you don't feel any pain, it don't hurt or anything. And it's even surprised us that it doesn't burn the skin for the most part. I guess some people have a real delicate skin that it can burn a little bit, but for the most part, this even 12,000 parts per million MMS doesn't burn the skin. So you can see that something that's that strong, when you're only drinking 25 parts per million, it can't possibly hurt you. On 12,000 parts per million, don't hurt you. So, of course, you can't drink 12,000 parts per million, of course, but you can put it on your skin and it won't hurt you. Anyhow, that's the point of it is that these are the things that you should purchase, and you ought to purchase 2 or 3, 4 or 5 extra nipples. So if you cut it wrong the first time, yeah, you probably will. Then you need to cut it the next 2 or 3 times, and you'll finally get a pretty good round hole on the top. Don't have to be perfect, because the rubber stretches really good. So everything is here. That's all you need to buy. Okay, you need to cut a hole in the end of the nipple with a really sharp pair of scissors. I'm going to show you this. Hopefully it may take a couple of times for you to get the idea, so you may have to practice with 1 or 2 nipples. But anyhow, you're going to cut right straight into the nipple at first, like this. And once you go straight in, then you're going to start turning it so that it makes a round hole in the end of the nipple. I hope that does it. You can see the hole in the end of the nipple there. It isn't the best hole in the world, but it will probably do the job. But I'm going to just trim it just a little teeny bit to make it look a little bit better at this one point here. There we go. We got more of a round hole this time. See, that's pretty much what you need in order to keep it from leaking. But most holes work as long as it ain't too big. So this hole would be pretty good. So that's basically the way you do it. I want to tell you a little bit about drops and test strips. Now, the 4 items on the right, the 2 white bottles and the 2 droppers, all make the same size drops. 25 drops to a cc or milliliter. Drops are a little more complex than the size of drops are a little more complex than you might think. It has to do with 2 things: the size of the hole, and then the size of the article or the item that the hole is in. So you can see here, I think, that you can see almost the size of the holes here. But in any case, these 2 eyedroppers have the same size drops, although they're a different configuration on the end, but they have the same size drops as the white bottles do. And so there's 25 drops on those 4 things that make a milliliter or a cc. Now, when you're talking about the red and the green bottles there, you have a different problem. The size of the drops depends upon how you hold those 2 bottles. And let me see if I can get a little bit closer so you can get a concept of what they look like on the end. That's the only problem, you see, is if you hold those bottles exactly upside down, you get one-sided drops, and if you hold them a little bit not exactly upside down, you get different size drops, and it just depends upon how you hold it. But it varies somewhere between 16 and about 22 drops for a milliliter on each one of those bottles. So they're kind of crazy bottles to use, but sometimes that's the only thing you can buy. But I hope that the suppliers will get a little better tops, because those tops just don't give you a consistent amount. In other words, if you might hold a bottle in one position one time, and the next time you hold a bottle in a slightly different position, and so you get a different amount. And it don't vary widely, it just varies a little bit, but it varies enough that it could be critical in some cases. Generally it won't be critical. Now this one other dropper here, let me show you it. It's the dropper with the green top there, and it has you can see, I think you can see the hole in the end of it. It has a big hole, and it takes about 16 to 18 drops from it to make a milliliter. So you see, it varies too, but it's consistent at least. and the other side. Now I'm showing you the test strips. The test strips measure parts per million, and they're sold by a company called Lamotte, Lamotte, and they're for sale on the internet. You can order them off the internet, and they're fairly cheap. Yeah, they're around $10 for a 50 test strips. I might tell you that what I do is I cut each test strip down the center. So instead of having 50, I have 100 test strips for the same amount of money, and it works just fine. Anyway, so this is about the test strips and the drops. So I think hopefully this will give you some idea of what your drops are giving you next time you're working with drops. And so that should be all for now, and thank you for your time. Okay, I want to show you this time, at this point, a dry run. I want to show you what we're going to do when we do the real run. But I want you to have some idea of what we're supposed to do when we do the real run, so it won't be that much of a secret to you. So the way we need to start off is we need this bottle, which you've already seen. We need 8 ounces of water in it. So I'm going to put 8 ounces in here of water, and just to give you an idea of what we're doing. Now we put 8 ounces of distilled water in here, and so there we go with 8 ounces of distilled water in a nice glass bottle. Now this already has water in it. I don't know if you can see it, but anyhow, it already has water in it. Now I'm going to turn this up to 2, because that's what I found that really makes this boil, or almost boil. You want the water almost boiling, but not quite boiling, just right on the edge of boiling, almost boiling. And so now we're going to charge the baby bottle with a 1 ounce of citric acid. These are 1 ounce shot glasses, and as you've already seen, these are, and this is the MMS, 1 ounce of each one of those. And when we put that normally in the baby bottle, it will immediately turn brown. But this is just a dry run, so it ain't going to turn brown this time. But you can see that I'm spilling a little bit of it. Won't hurt anything. And so we got that. Now I'm going to charge I'm going to close the baby bottle, of course, with the nipple. Put the nipple on nice and tight. And I'm going to put it in the water, and the water should be fairly warm at this point. And then you don't have to wait until the water is fully hot, but it's a good idea to wait. It's a good idea to have it pretty warm when you put it in, so that you can see the bubbles starting right away. And if the water is pretty warm, the minute you put this in here, there's going to be bubbles coming out of here. So that's basically what we're doing. And of course the clothespin just holds it down so it don't come out any on us. So we'll have the chlorine dioxide gas coming over here and bubbling into here. And that's why, and Not all the chlorine dioxide gas stays in solution. Unfortunately, some of it comes out, and that's what we lose. And that's the reason why we have the fan right here blowing across here. And I have a fan in the window that that blows out the window, so I'm okay here inside. But you probably should be outside on a porch with a fan blowing across, or outside in the garage or something with a fan blowing across, because you need a fan both places. A fan in the window blowing out and a fan blowing across that way. Because if you get a couple of really heavy whiffs of chlorine dioxide, you're going to feel a little sickish, or you're going to start coughing or wheezing or something. So you don't want to breathe any of that chlorine dioxide. It's not what you consider dangerous, but anybody who can be, stupid can wind up with a problem. But as long as you don't breathe very much of it, it isn't going to hurt you any. Now, this should be bubbling over here for about 20 minutes, that's all. And by the time 20 minutes is up, if you lift this up and look at it, or if you just look at it in there, you're going to see that it's watercolor. You're going to see that most of the color has gone out. Might be a little teeny bit of yellow in there, but most of the color is going to be gone out of there in 20 minutes if you have the right temperature, and that is almost boiling. And of course this won't be boiling, but it might look like it's boiling because there'll be bubbles coming out. And anyhow, just keep this pan just below boiling and you'll be okay. Now, when the 20 minutes is up and you look in there and you can see that most of the color is gone, you're ready to take this out, and you're ready to measure this and make sure that it's a proper strength. Now, there are two ways to measure this, and you can measure it two different ways. I'm going to show you both ways because the easiest way would be using the strips, parts per million strips. Now you want this to be 3,000 parts per million. That's what standard CDS is. Now, CDS is. Standard CDS is 3,000 parts per million. But now you need to use these strips to verify that. And the way you do that is that you take and you want to put 9 milliliters in here, 9 milliliters of water, clean water, preferably distilled water. Now you can adjust this to 9 milliliters really easy. And now you squirt 9 milliliters in there. Now you want to put 1 milliliter of this, so don't spill it, try not to spill it. And you want to put 1 milliliter of this, exactly 1 milliliter there, in here. See? Now you might have just a slight color in there. And now you're going to measure it with one of these strips. Now, what I want to measure is, I want to measure 300, but we've diluted it 9 times, so we have 10 parts there. Now I'm going to drip this in 1, 2, and bring it out. I'm going to wait my 10 seconds, and I'm going to measure it here, and it should measure 300. It should measure 300. And you can see that it will be 300 on there. If you were actually doing it, it would measure 300. I'm going to show you the actual thing next, but now that it should be 300, and you measure, and of course we diluted it 10 times, or we diluted it 9 times, but the total that we had was 10 parts, and one of those parts was CDS. And so that CDS is, so we can multiply by 10, and that 300 times 10 is 3,000, and that's what we want. So if that was 300, we would have it, okay. But it may not be 300. If it ain't, if it's less than 300, then we're going to have to redo it, add more to it. Or if it's too much, we can add a little water to dilute it down to 3,000 parts per million. So however we do it, we want to do it so that it winds up at 3,000 parts per million. You can figure that out, but remember, if it's, we put 9 milliliters in here, and we add 1 milliliter of this to it, so that's a total of 10 milliliters. And so whatever this little device tells us, we can multiply it by 10 to really tell us what's in that bottle, because we've diluted it here. Okay, now the next thing is, maybe we don't have these strips. A lot of places in the world you can't buy these strips. And so if you can't buy them, or if you don't have them for one reason or another, most places in the world you can go get Gatorade. And not everywhere, but most places. And so most places, even in the jungle, most places you can get Gatorade. So now we have this one, and I'm going to then make another one that's the same amount, which is 1 ounce, exactly 1 ounce we're going to put in there. And it's a little tricky because, but we get mostly 1 ounce in there. That's pretty damn close. Anyhow, so now we're going to take 1 milliliter of this again, and we're going to take 1 milliliter out of here, and then we're going to squirt it in here. Now remember, this is a dry run, so everything ain't working, but we squirt 1 milliliter in there, and we wait. 1, 2, 3, 4, 5, 6, and in 6 seconds this has to be green. You can evaluate the two against one another. This is a light green, it's light blue now, it is a light green. In 6 seconds we have 3,000 parts per million. If it takes 7 or 8 or 10 seconds, then you know that this is not 3,000 parts per million. You're going to have to do this thing again. Now, if it goes, say it goes in 3 seconds instead of 6 seconds, well, that means it's a little too strong. So we can add some water to this. We can add some of this water to this in order to bring it up, in order to bring and dilute it down, actually, in order to dilute it down to 3,000 parts per million. So remember, if it goes in 6 seconds, it's 3,000 parts per million. If it goes in 10 seconds, it's still too weak, and we're going to have to use some more of the CDS gas. And if it is, that's chlorine dioxide gas. And then if it goes in 3 seconds, it's too strong. So we need to add some water to it. So that's the basics of the dry run. And now, in just for you, it'll be about 1 second. We're going to start on the wet run, the actual run. Now there's more than just, we're going to do 2 actual runs. One, we're going to do the 3,000 parts per million. We're going to make it 3,000 parts per million. But then I want to show you the new thing that we've been doing here at the world headquarters. And the new thing is we make 12,000 parts per million. At 12,000 parts per million, instead of the dilution that we're using now, it's 2 drops of CDS equals 1 drop of MMS in all of the protocols. So it's 4 times as strong, so that instead of it taking 8 drops of CDS to equal 1 drop of MMS, it takes only 2 drops of CDS to equal 1 drop of MMS. It's easier to use that way, stronger, and sometimes it's more effective when you spray it on various different things on your body. It's much stronger, and we have found here that it is more effective in a lot of cases, so especially for spraying on the body, and you don't, we're still drinking it at about the same strength, just using less drops, but it still winds up at the same strength. And what you want to do is always to check it with these strips. You check your final water, which that you finally make, your final solution that you're just about to drink down. That solution needs to be somewhere between 25 and 50 parts per million. 25 and 50 parts per million for the solution that you drink. Now, if you want to do a 3-drop dose, you would use, if you have a 12,000 parts per million, then you would only have to use 6 drops for a 3-drop dose. Now we're just trying to get it easier to use, that's all. And when this is 12,000 parts per million, it's 2 to 1. So if you were going to do a 3-drop dose, then you would have to use 6 drops of this to equal 3 drops of MMS. Now we'll be making up a book showing how to use CDS, so you won't have to keep translating back and forth between MMS and CDS, but right now that's sort of necessary, and I'm just trying to tell you how to do it. So, and I'm going to show you how to make the 12,000 parts per million. We'll go on those 2 next in just 1 second. Now I'm going to show you the actual operation. And so first though, I wanted to show you that we have a fan here. And that fan is an important thing to have, because if you don't have that fan going, you're going to get a breath of chlorine dioxide gas, and it ain't going to be good for you. So now what I'm going to do is show you how to do it. And I have already put 8 ounces of water in here, and and now I'm going to charge the baby bottle with 1 ounce of MMS and 1 ounce of citric acid. Now you got to have that, because that's what it takes to handle 8 ounces of water. So here we're going to put 1 ounce of MMS in here. And I'm going to put 1 ounce of citric acid. This is citric acid. In here. Now these are 1 ounce shot glasses, exactly 1 ounce. So if you get them full, they're 1 ounce, and close enough for government work. And so now I'm going to charge the baby bottle with 1 ounce of each one of these things. So here we go, 1 ounce in the baby bottle. Now watch what happens when I put this other one in. It starts turning color right away, you see. Now, we're going to put the lid on here. I'm going to tighten it down good and tight. Now this is a bottle, this is a nipple that you already seen me cut the end open. And now I'm going to put this, don't worry, there's no germs on after the MMS gets to it. Okay, so now I'm going to put it in the hot water. There's hot water there, and you'll notice that the bubbles start pretty soon. You see, the bubbles are already starting. You can see the bubbles coming there, and so very simple. It wasn't no big deal, right? And so we need to wait until that is completely done. It's going to take about 20 minutes. So I'm going to sign off now, but I'll be back in 20 minutes, which is for you about 2 seconds. Okay, here I am back in about a half hour, and I can show you that the bottle is clear now. Remember, I put it in there, it was pretty dark, almost real dark brown. Now the bottle is pretty clear. There's a slight yellow cast to it, but that's plenty good enough. We've got 99% of the chlorine dioxide gas out of there, and you can see how dark this bottle is. It's pretty dark. That's 8 ounces of water that we've treated, and we're gonna measure the parts per million in that. It's in this bottle. Now, the first thing we're gonna do is measure it with the test strips. I'm going to show you how to do it with the test strips. We're going to find out how many parts per million this bottle is with the test strips. Now, the first thing I'm going to do is I'm going to put 9 milliliters of water in here. Hopefully it's distilled water. And I'm going to measure that out to exactly 9 milliliters. That's it, 9 milliliters in there. Now, I'm going to put 1 more milliliter in there to make 10 milliliters. And so I'm going to measure 1 milliliter with this, so of the CDS. Measure out just exactly 1 milliliter. Stir it in a bit. Now, we're going to measure this and see what it tells us. Now you see that I just did a 10 to 1, a 9 to 1, but it's 9 milliliters plus 1 milliliter of this, and that's 10 total. Now we're going to see what this answer gives us. Whoops. It's more. See, I don't know, you can't see that, but anyhow, I'm going to show it to you whether you see it or not. It's darker than the darkest thing on here. So that means that it's more than 5,000 parts per million. So that turned out pretty good. Now, so what we want to do is to add an ounce or 2 of water and see if we can bring the parts per, well, we can bring the parts per million down, of course, but the point of it is well, here. Okay, I'm gonna add 1 ounce to it. No, I'm gonna add more than 1 ounce. I'm gonna add about 4 ounces. So that was 1 ounce I just added, and I'm gonna add 3 more ounces, which brings it up to, I'm going to add 3 ounces, which would be a total of 4 ounces. This is 3 ounces more, so that's a total of 4 ounces we've added to it. Well, let's shake that up. Make sure it's mixed good. Now let's see what the parts per million is. Now I'm going to have to dump this out. Put some more water in here. And put another 9 milliliters of clear water in here. So I'm going to measure out exactly 9 milliliters. That's 9. Put that in there. We're going to put 1 milliliter of this in there. There we go, 1 milliliter. Now I'm going to measure that. And let's see how it comes out. 1, 2. Whoops, that was a bad one. Have to try another one. It's not as bad. There, that's a good one. 1, 2. Oops. Well, okay, that measures out at about, well, that's somewhere around 4,000 parts per million, you see. I don't think you can see it from there, but in any case, that's measuring about, that's saying about 400, but we're multiplying it by 10, because we have 10 parts, here, and 1 part was from here, so that would be 10 times that, and 10 times 400 is 4,000. 4,000 I'm going to be satisfied with for now. We could dilute it more, and that's what you would probably want to do. You'd want to keep diluting it until you got it down to 3,000 parts per million, which would show up on here. So you can do that. Now, the next thing I want to do is I want to show you how we do it with Gatorade. Now here's 1 ounce of Gatorade is in here, and that's just for, now I'm going to put the same amount in here, and then again we're going to use, of this, we're going to use 1 milliliter again. Here we go. Milliliter. Now, if it's 3,000 parts per million, we know that it's going to cancel this blue out in 6 seconds. But, so let's see what we do. 1, 2, 3, 4, 5, 6. See? No more blue, it's all green. And it was actually canceled out in about 5 seconds, which proves that we have a little bit stronger solution than 3,000 parts per million. So that's the way you do it with Gatorade. Unfortunately, it just gives you a good idea, but that's all you need for this. We're not exacting science. It isn't, but it is, as long as you get close, you're okay. And so we're close, and you could use this the way it is, and you'd be getting a little stronger dose than you really need, or you can dilute it out a little more until it gets all the blue is gone. You're comparing these two, and you're comparing the blue is gone. So the actual blue was all gone in about 5 seconds. And so add some more water in there and try to make all the blue be gone in 6 seconds. So that wouldn't be that hard to do. Now, that's basically how to make standard CDS. Now I'm going to show you the next step on how to make better than standard CDS. So I'm going to show you how to make the extra strong CDS. That would be 2 drops equals 1 drop of MMS instead of 8 drops equals 1 drop of MMS. So it's a little easier to use, and a lot of people are preferring the stronger CDS. And I have gotten better results on certain skin diseases with the real strong CDS. Putting it on there full strength at about 12,000 parts per million, it seems to kill off some skin diseases a lot faster when it's really strong. And it doesn't burn or hurt when you put it on either. You hardly feel it, and then it kills a skin disease. So it's maybe worth being able to do it, so I'm going to show you how to do it. So that is in the next scene. Okay, this is the next and last step here. How to make CDS that's 12,000 parts per million. Now 12,000 parts per million means that you can follow any of the protocols for MMS, but you have to use 2 drops for each time MMS calls for 1 drop. 2 drops to 1. So the CDS at 12,000 parts per million is just exactly 1/2 strength of MMS. But so there's big advantages to using CDS, and I didn't mention it, but before, well, I did, but anyhow, we're getting much better and better results from CDS. A lot of places, from the jungle, a lot of places are telling us that they're getting better results from CDS, better and faster results. So that is amazing in itself, and so I think a lot of people are going to want to use it. It has no taste when you're doing the standard doses, and it is easy for people to take, and nobody balks at taking it, so it's very easy to get it going. So I'm going to show you how to make the strong stuff right now, and the simplicity of it is we're going to use the same way. Well, it isn't going to be any different, but I'm using only 4 ounces. This is a 4-ounce bottle instead of 8 ounces. So now I'm going to put 4 ounces of distilled water. Actually, this is reverse osmosis water in here, and then we will charge this, and several times we'll charge it, and we'll check to see when it's 12,000 parts per million. So now this is 4 ounces, maybe a little bit more. It's a 4-ounce bottle, but I got it filled way up to the top. 4 ounces of reverse osmosis water. We put it all the way down in the bottle there. This goes all the way to the bottom, of course. And now we want to fill a baby bottle. We're only going to put 1 ounce of MMS, or 1 ounce of citric acid in here. So we have to measure it out. I think you can see this. Here is 1 ounce of MMS going into this bottle, baby bottle. There it goes. Wow, didn't even spill any. Now, we did that. Now we want to put 1 ounce of citric acid in here. So this is citric acid being measured out, 1 ounce here. So here goes the citric acid in it, and I want you to notice that what happens when I pour the citric acid in there. Notice that it bubbles up and turns brown right away, and it's starting to outgas right away. So we put the lid on it. Now I want to tell you one thing, and I hope you listen to this one point because it's very important. This must be fully hot when you put this in it. You can't put this in cold water and then let it and then turn it on. And you can do it. You can put it in cold water, but you only get about half as much fluorine dioxide gas out of it. I don't know the real reason, chemical reason for it. All we know is that we get much better results when we put it in fully hot water. So I'm going to put it in the fully hot water, and I'm putting this in the hole in the top of the nipple that I already showed you how to do. And this goes to the bottom over here, and I'm putting it in there right away. Oh, it's not bubbling right away, so that tells me one thing. This lid is not on perfectly and it's leaking. So we have to take the lid off and put it on better. Okay. Okay, it's on better this time. Don't worry, the germs are killed by the MMS. Put that in, make sure it gets in there so it isn't going to leak. You got to put it down in that hot water like that. And you can see that the bubbles are starting right immediately. It's bubbling right away. The reason why I'm putting it in the glass is that it would tip over otherwise. So the glass is keeping it from tipping over, basically. That's all the glass is doing for us. And now we're just going to let this go to an endpoint. Like I said before, what we do is we just let it go until all that brown color and black color, or whatever you want to call it, turns white, like water, or almost white. And you can see this is already starting to turn yellow. And it will be plenty yellow. And I got to turn my fan on. You saw the fan in the last movie. Now this, I'm going to come back. I'm going to go away now, and I'm going to come back in 20 minutes, and we're going to do this again. You see how yellow it is already? That's because I put it in hot water. If I didn't put it in hot water, it wouldn't even be hardly turning yellow by now. So The hot water is very important. The water has got to be right on the edge of boiling. If it's slightly boiling, it won't hurt anything. But it has to be hot water that you put that in. And if you put it in the hot water, and it'll start bubbling right away, and you'll have a really strong solution. You may get 12,000 parts per million from the first run, but I don't think so. But we'll check it out when I come back. So be back in 20 minutes. Okay, I'm back in 20 minutes now, and I'd like to point out that most of the color is gone out of the bottle. It isn't all gone, but enough of it is gone that I'm willing to go to the next step. Normally, you might wait another 10 minutes and let it go a little bit longer, or maybe even put some more water in there and turn up the heat a little bit. But for now, we're going to continue to the next stage. Let's test this and find out what the parts per million is. The best way to do that, of course, is to read it on the strip, the test strip, which tells us parts per million. But we've got to dilute it, because it's going to be too strong to read like it is. So we're going to have to dilute it 10 to 1. And 10 to 1 is really 9 parts water and 1 part this. So we got 9 parts of water in there, and we're going to put 1 part of CDS. And of course that means 1 milliliter of CDS and 9 milliliters, making 10 total milliliters. And so let's see what that reads. Looks like it's going to be pretty heavy reading. That's 10 to 1. So that went off the scale. So that means it's more than 5,000 parts per million already. I won't bother to read it again right now. I'm just going to redo it, and this time I'll use this other baby bottle, but I'll use the same nipple. And so I'm going to put an ounce of, oops, I don't think I have an ounce of each of those. So I'm going to have to go off of the screen and get some more supplies. So I'll be back in 1 second. Okay, I'm back with the necessary supplies. So the first thing I'm going to do is add an ounce of citric acid to this baby bottle. Okay, there's the citric acid. Now, next thing I'm going to do is add an ounce of MMS to the same baby bottle. And of course, you'll see the same reaction. I dump it in, bubbles, and it turns dark right away, right? Okay. Then we want to make sure that we get the nipple on good and tight so it don't leak. And you got to be really careful about that. It doesn't leak. Don't worry, no germs. All right. Now we're going to have to put it in here and it'll start boiling. Well, the water isn't completely hot and there isn't enough water in there, so I'm going to add a little water. Now, the water isn't completely hot yet, but it's warm, but it's not really hot. And you should never put it in unless it's completely hot, because well, I don't know what the reason is. But the reason that we don't do that is because it only gets all of the chlorine dioxide out of the bottle when you put it into a completely hot situation, a completely hot water that's boiling or right on the edge of boiling, and that water isn't hot enough to put it in there yet. So I'm going to wait a minute before I put it in, but I'm going to set it up so we can put it in just a minute. And well, I'm going to do something that I tell you guys not to do because we're on camera. I'm going to go ahead and put it in there, and you'll see that it starts bubbling right away. So we aren't lost too much. The main thing is it starts bubbling right away, but normally you shouldn't do it until that water is boiling or really on the edge of boiling. If you do that, then if you wait until the water is really boiling, then right on the edge of boiling, but there, plenty hot, then when you put it in, you know you're going to get the maximum amount of chlorine dioxide gas over to here. But I don't think that the way we did it, that it was almost boiling, so it was probably pretty close to okay. So now I'm going to come back in 20 minutes, and we'll then evaluate the parts per million of this. And you'll see how I do it for something that's really strong. Okay, back in 20 minutes. For me, 2 seconds for you. Okay, this is a little more than a half hour later. I want to show you that this is turned watercolor. No gas left in there, no CD gas left in there at all. Bring that out of there. And so, at least in theory, all the CD gas is in here. So let's find out what the parts per million of this actually is. And the way we'll do that is we'll put, instead of, let me turn this off all the way. I'm through with that. Put that down there for now. I want to touch that up. So enough there, though. Okay, now I'm going to dilute it by 40 times instead of 10 times. So let's go here. Okay. We have 39 milliliters into which we are going to put 1 milliliter of the CDS that we just made. Now, so I'm going to get exactly 1 milliliter there. That's 1 milliliter. Notice that it is still pretty yellow. Now we're going to measure that with one of these strips, measuring strips, and 1, 2, and we have a completely black, I don't know if you can see that, probably not, but anyhow, that's a completely black one. If it went brown, if it went black and then went beyond black into the brown, then it would be beyond measurement, but it looks completely black, so it looks exactly like 500. So we're going to measure, we're going to multiply 500 times 40. 4 times 5 is 20. 500 times 40. So we got 20,000 ppm. That's a little too strong. So we're going to have to dilute it down some. And I don't really have anything to dilute it with at this time. But what I would do, if I were going to dilute it, is I would put some of it out into some other container, and then that is like 20, and we want it to be, so I'm going to dilute it by about 1/4. I'm going to add water up to here, and let's see what we get. So let me add the water up. Okay, that's diluted that much by 25%. Let's see what kind of reading we get out of this, huh? Okay, we need to do the same thing. We need to be able to we need to be able to put 40 milliliters in there, or 39 milliliters, and then from that, whoops, don't work. We can do it. We can do it with the glass. Okay. I'm going to do it. Sorry about that. I needed the fan to be running. And this is 39 milliliters. Okay. Excuse me. And I'm going to put in 1 milliliter in here. So that's going to be 40 to 1. Okay. 40 to 1. Let's see what we get with that. We diluted it out. 1, 2. Now, it's reading about 250. It's reading about 250. Now you can't see that, but anyhow, I can see it from here. It's reading about 250, and that's times 40 is 10,000, but about. So we could put some of the more stronger stuff back to get it up to 12,000. So that's not as good as I can show you right now on this CD, because I didn't I expect that it would be that hard, but I hope you can see that we could use this at 10,000 parts per million. It's probably closer to 12,000, just depending on how you evaluate the color on here, and that isn't really that close. So 10 or 12,000 is pretty hard to evaluate against. Sorry, but this is not what you call rocket science. It's making people well, and we don't have to be perfect. If we were a scientist and we had millions of dollars to do this with, we would have it all perfect. But unfortunately, it hasn't produced millions of dollars yet. We've just made a lot of people well and stopped a lot of suffering. So if we don't have everything perfect, it still works. So anyhow, you got somewhere between 10 and 12,000 parts per million, and that means you can get away with using 2 drops of this for each drop that the protocol calls for MMS. So if MMS protocol calls for 3 drops per hour, then you could use 6 drops of this per hour, and you could be pretty sure that you would have the proper amount. And of course, way all the protocols are set up, especially actually protocol 2000 is set up, is that you use as much as a person can stand without getting sick. So if the 6 drops you used wasn't enough, you could use 7 drops. And if it was too much, then you could use 5 or 4 or 3. So you go by the person, how he's feeling. So the fact that you didn't get exactly the exact amount is what the person himself can take without getting sick. So that's the simplicity of it. And so we don't have to be perfect with this, because we know that we got to watch the patient and determine how much to give him, not how much exactly is in here. But this is close. This is close, and it will do the job. And so I think you understand how I did it, and I think you see how it can be done. Most of you can. If you can't, you can get somebody to help you. Maybe the local high school kid can help. or maybe somebody else. But in any case, or you can just buy your CBS. They're selling it now. So either buy it or make it. And good luck to you. I appreciate your help, all of you out there, and your backing.